Hey, Mr. J here with a little tutorial on a couple of the skills you need for this project. So just refer to this video if you want to know how to use the GeoGebra piece or to do spreadsheets. So let's jump right in. So go to GeoGebra Classic, which is the one we go to. I like geometry, but you can also, if you end up on the graphing page, you can just turn off the grid and turn off the axes, and you're in the same place. Also, if you don't have the algebra window, if you're here and you need the algebra window, which you do, open the algebra window here. So you need both of these. This is where you should be starting. And make sure you bookmark this. You can drag this into here, and it would be easy to start if you haven't done that already. I'm going to do an analysis, I think, of Homer Simpson. See if the golden ratio is in Homer Simpson. So let's just take a nice picture of Homer. This looks like a good one, and we'll save that, save image on the desktop. And I know you can do this on the Chromebook as well. So desktop Homer Simpson. And come back to here, and I think it's in here that we add image, that A equals 2, choose file, desktop, look for Homer Simpson at the bottom, and see if he comes in. Alright, so let's see if there's a golden ratio that the artist who drew Homer Simpson, if he was or she was thinking the golden ratio existed. So we're going to put segments onto him. And we'll go from the top of his head to his belt line, to the bottom of his shirt, and then from there to the bottom here. A little hard to see. If that happens because of where it is, you can also change the color, make it stand out a little bit more, or make it thicker. And then maybe make this one blue. And we can make that thicker here too. And it should be straight. I don't know if I'm perfectly straight, but I don't know if that makes too big a difference. You know, I don't really want it like this, but I could have it pretty straight. And now I want to do the calculation. So over here in input, let's create a variable. I'm going to call my variable ratio1, and it will be the ratio of f divided by g. You see the f and g? F slash g. And it comes out to 1.64. If you want more decimals, go into the 3 lines here, settings, and let's go to 5 decimal places. Close that. Now we have some better data there. And what we're going to do with this now is I want to put it in a text box out here. So come over here and say text. And we're going to just say golden ratio equals, and we need to go into advanced. We choose latex to do a fraction, and so it puts in this little bit of code which will tell it to write it as a numerator denominator setup, and we'll replace the A with a special, not just A, because that would just put the text letter A. We want it to be the GeoGebra, and it's letter F, and then the denominator will be the second one, and that's going to be the G. And that should equal ratio 1, which we have as that fraction, or the ratio. And now that looks pretty good. We can edit it if it needs to be. You can't change the size here. I think you can change the size over here if you want it a little bit bigger. And the nice thing about that is if we import another picture, so take your screenshot here, and then maybe we do a different picture. Maybe we choose Marge Simpson. All right, and let's see, Marge right here. And we're going to save that image on the desktop. So it's some strange number. And I'm going to import that into here. And watch how easy this can be then. Image, choose file. And what I'm going to do now, so I've taken my screenshot with Homer, and then let's just move Homer out of the way. Let's move Marge in, make her bigger. Let's choose where we think is significant for the artist, maybe that hairline, that seems significant. Not quite straight here. Maybe more like that. And now everything's already done. You see how I have all my calculations. Oh, but I got it flipped, so let's make sure we rearrange this. and the red is the shorter piece. We put it here and there, and doesn't look as clear. Now you are deciding where the significant spots are that you're going to put your segments, but you could take a screenshot out of that and you could then move Marge out of the way and bring in your next picture. And this is the same kind of analysis you'll do when you're doing actual calculations of phi, when you're doing, say, a regular pentagon, and you know, extending the sides possibly to find a golden ratio, but the same kind of analysis of comparing segments, okay? The other thing I want to talk about is just a spreadsheet. So let's go over to a spreadsheet. I want to show you that calculation. Try to keep this video pretty short. So let's do a new spreadsheet. File, new. So everybody's going to do what's called an error analysis, and it will have these headings. It'll be a long, what am I typing? Long side, short side, ratio, phi, absolute value difference, error rate. And let's go ahead and center all these. And so let's just put in some numbers like 24 and 18. They're just making stuff up. These would be the measurements you take off GeoGebra. You're going to put equals, which tells the spreadsheet it's a calculation, and you divide that by that. So C5 divided by D5 with an equal sign. Put in the actual value of phi of 1.61803. Absolute value difference equals ABS of the difference between these two. This is how far away they are by subtraction, but only the positive answer. And then we divide this by phi. So how far away are we from phi? And then I like to make that a percent. And these decimals don't need to be quite so big, so we can make them, that's bigger decimals, that's smaller decimals. And these are the calculated cells, so we can drag those down by going to the corner, and then you can enter your other data just in these cells here. Let's make those, I like to make them say yellow to say this is where we're going to put them in, and we're going to put a grid around them. So now we're set up to do the other calculations really quickly. Say I put in 13 and 8. Those are Fibonacci numbers, which we know have a pretty close to phi ratio. You can see the error rate's really small. If I do the next Fibonacci series, 21 and 13, even closer. If I do the next one, 34 and 21, I'm getting even closer to phi. And what's that, 55 and 34? Very close. And then what you do is you do equals average of this column here, and the math is done for you. So pretty quick process to make a little spreadsheet. I want to just develop that skill. Really useful, and you'll see it's dynamic. Like if I change this number here to 25, everything changes, right? If I change this number to 17, everything changes. And then you'll put this on your website, okay? So I think that's it for our video.